Oh, hello. I realize I'm on mute. What's up? You are also punctual. It is absolutely lovely. आवाज आ रही है? Yes. Hello again. What's up, Deepanvita, Teerth Raj, and everybody else that is watching this. बाद में. Hello to you as well from the other side. No, I'm not doing that. Hold up. I like the other hello song better. वीडियो कहाँ गया भाई? वीडियो कहाँ गया? अरे, एक सेकेंड. And now, yes, you should be able to see me right about now. I am visible now. Yes. Invisible, I am visible. Yeah. Rajan, yeah. Okay. We meet again. We meet again. Good evening. फिर से. Yeah. All good. ठीक है. Cool. So, we've done क्या किया अभी तक? We've done classification. We've done nomenclature. Let's look at the different theories that were used to try and understand coordination compound. Right? It's a very fascinating thing. The fact that these kind of compounds form. Look, हम लोगों ने बोला कि एक square box के अंदर we can represent the formula. But the most crazy thing about it was what Werner discovered. And it may seem very, ठीक है, what's a big deal right now? But it was absolutely insane. Okay, so let's talk about what Werner discovered, so to speak. Yeah, there are a lot of these theories. We'll talk about this one and this one in this session. ठीक है, Werner and VBT, crystal field theory, अगली बार. ठीक है, Werner भाई साहब ने कुछ experiments किए, right? He tried to explain the bonding in these compounds. Here's this beautiful guy. Look at him. Look at him. He got Nobel Prize in 1913 for linkages of atoms and coordination theory. Okay, so he took some complexes of cobalt chloride with ammonia. So he took cobalt chloride, made it react with ammonia right there. I'm going out of the frame. Okay, made react this cobalt chloride and ammonia, and he got all of these different compounds, like 4 different compounds, right? Different ratios of ammonia and cobalt chloride. First one had the formula of COCl 3.6NH3, right? The other one, next one is this. When he mixed in a different ratio, he got CaCl 3.5NH3, and lastly, right at the bottom, he got CaCl 3.4NH3. अरे नोबेल प्राइज रविंद्रनाथ टैगोर जी. हे दिवांशी, हे दीपान्विता. अरे वाह तीर्थराज जी, दिस इज वेरी गुड पीस ऑफ ट्रिविया. रविंद्रनाथ टैगोर, व्हाट अ ब्रिलियंट पोएट, व्हाट अ ब्रिलियंट पोएट. खैर, so now what he did was, okay, 4 different compounds मिल गए. Did you notice one thing, by the way? Same formula, 2 compounds, मतलब they must be isomers. What kind of isomers? इसका जवाब मिलेगा अगले एपिसोड में ऑफ कोऑर्डिनेशन कंपाउंड्स. Yeah, we'll talk about this. दो अलग अलग कलर, सेम कंपाउंड, we'll talk about that बाद में. खैर, what he did was he added a lot of AgNO3 solution. ठीक है. Do you remember this is a preliminary test of confirming the presence of chloride ions. AgNO3 डालो, सफेद प्रेसिपिटेट मिला, मतलब क्लोराइड आयंस प्रेजेंट है. अगर येलो कलर का प्रेसिपिटेट आया तो इट कुड बी ब्रोमीन, आयोडीन, एटसेट्रा एटसेट्रा. ठीक है, अलग अलग कलर के प्रेसिपिटेट आते हैं अलग अलग विद AgNO3. दैट वाज द होल ग्रुप 1 एनायंस वाला टेस्ट. यार डाइल्यूट HCl के साथ करो, फिर उसके बाद ये करो, वो करो, AgNO3 ब्ला ब्ला ब्ला. Anyway, group 2, sorry, not group 1. Group 1 was carbonate and sulfide. याद आ रहा है कुछ? Practical chemistry के वीडियो देख लो, प्लेलिस्ट में बने हुए हैं. Anyway, so he added AgNO3 in excess and he got these results. Okay, पहले in this one, if you took 1 mole of cobalt chloride, COCl 3.6 NH3, and a lot of AgNO3, he got 3 whole moles of AgCl3 that precipitated. Okay, this gave 3. Okay, because एक मोल में ऑफ दिस कंपाउंड देयर वर 3 क्लोराइड आयंस. ठीक है, हो सकता है. देन थिंग्स वर इंटरेस्टिंग. व्हेन यू टुक दिस कंपाउंड, ये दूसरा वाला कंपाउंड, इस बार उसको मिला 2 मोल, एंड थिंग्स बिकेम इवन मोर इंटरेस्टिंग. ये हरा वाला लिया तो मिला 1 मोल, और ये वायलेट वाला लिया तब भी मिला 1 मोल. दैट्स क्रेजी, दैट्स क्रेजी. बिकॉज इन ऑल ऑफ दीज, वापस जाता हूं मैं, गोइंग बैक अ लिटिल बिट. ओके, इन ऑल ऑफ दीज, look at this. The compounds all have the same number of chlorine atoms. That's what I want you to notice. Okay, इसमें है 3 chlorine atom, इसमें है 3 chlorine atom, इसमें भी है 3 chlorine atom, इसमें भी है 3 chlorine atom. But all of them give different amounts of AgCl. If you want to see everything in one place, look at this, right? In the one with 6 NH3, you got, okay, wait, all of them are 1 mole of these guys. इन सब में बहुत ज्यादा डाला AgNO3. ठीक है, lot of AgNO3 सर के ऊपर मेरे in excess. There's a good band, in excess, in excess, by the way, music if you're into it. खैर, पहले वाले ने दिया 3 मोल, दूसरे वाले ने दिया 2 मोल, और लास्ट वाले दो ने दिया 1-1 मोल each. Yeah, the white colors trying to show this. Yeah, that's crazy. That's absolutely crazy. And what helped him prove that something was up was when he did conductance wale test. जिसने दिया 3 mole वाला, that showed the highest conductance. Look at that, 390. This is the 3 mole one, right? 3 mole AgCl one. This is 2 mole AgCl, right? That gave 261. And बाकी ये दोनों 1 mole AgCl वाले gave come this thing. So it looks like जितने ज्यादा chlorine atoms उतना ज्यादा conductivity. Yeah, yeah, yeah. Chat is quite silent. Oh, I've become very blurry. Oh my God. Yeah, man. This webcam is weird. It does that. Hold on. Let me fix that. Let me turn it off and turn it back on again. Yeah, that should be better. Everything is good, right? You guys have any doubts in what he's done so far? So because of this, he said कि यार दाल में कुछ काला है. Some of these atoms are bound in a way so that they don't dissociate in water, right? पानी की यही तो स्पेशलिटी होती है. कोई भी सॉल्ट डालो जो सॉल्युबल है पानी में, that immediately gives you ions, right? And यहाँ पे that immediately giving ions वाला part थोड़ा shady है because it's not happening as expected. Okay, that is what was fascinating and that was the conclusion. Okay, ये जो square bracket हम लोग डाल रहे हैं और इसका जो बाहर chlorine atoms है, let's say X amount of chlorine atoms, this is what is being ionized. Okay, so the number of chlorine atoms, let's say Y, ये X and Y ये बदलते रहते हैं in all of these compounds. That was the first thing that he figured out. So he said, he theorized that, okay, that maybe this is what the compounds actually look like. The formula of the first one is this, the second one is this, the third one is this. Third and fourth have the same formula, but they have some sort of isomerism. ये भी है आपकी formula, आपके what do you call it, syllabus में. CFCl3 4NH3 का शिफ्ट कलर डिफरेंस है. ये सिर्फ कलर डिफरेंस है. यस तीर्थ महाराज, कलर इसलिए अलग है क्योंकि वो दो अलग आइसोमर बनाते हैं. आइसोमरिज्म के बारे में आप चाहो तो एनसीईआरटी में पढ़ लो, या अदरवाइज वेट फॉर द वीडियोस कम आउट, वी विल डू दैट. सो दिस इज सेइंग दैट दिस इज अ 1:3 इलेक्ट्रोलाइट, 1:2 इलेक्ट्रोलाइट, 1:1, 1:1. इसका क्या मतलब हुआ 1:3? मतलब कि 1 मोल दे रहा है 4 मोल आयंस. ओके, 1:3 मींस 4 मोल्स. 1 कैटायन, 3 एनायंस. ये है कैटायन आपका, ये है एनायंस, राइट? 1:3 का ये मतलब हुआ, 1:2 का ये, 1:1 is this, 1:1 is. All right, cis and trans. Rajan, you're saying cis and trans? Maybe. We'll see. Yeah, good stuff. मतलब आप लोग already पढ़ चुके हो. That's great. So this is more of a revision for you guys. This is awesome. Okay. So both of these have similar formula and very different properties. Okay, these are isomers. Anyway, let's look at some postulates of Werner's theory. ये आप already जानते हैं, so it will be more of a revision. So we can maybe go over this a little quickly. The first thing he said was, okay, there are two types of valencies or linkages. Primary valency, मतलब जो ionizable है. This is the thing we put in the bracket, right? Cobalt 3, ये वाली, that's ionizable valency. Secondary valency, non-ionizable, मतलब ये 6. जो नंबर 6 था, coordination sphere. This is the non-ionizable one. So primary ionizable one is the thing that gives you, okay, कितने electron निकल रहे हैं, okay, and that is what is satiated by the satisfied, satiated by the negative ions. Chiral, that's interesting, Vaishnavi. Chiral, हो सकता है chiral भी हमारे, हाँ, we are going deep into isomerism, huh? Very interesting. We'll keep our discussion to isomerism to another session. Let's focus on the basics right now, right? ये है इसकी primary valency, मतलब oh, okay, इस चीज से डिसाइड होता है इसकी प्राइमरी वैलेंसी क्या होगी. ओके, कितने हैं. ओके, सेकेंडरी वैलेंसी गिव्स यू द शेप ऑफ द मॉलिक्यूल. वेरी इंटरेस्टिंग. इट्स नॉन आयोनाइजेबल, इट्स सैटिस्फाइड बाय द न्यूट्रल मॉलिक्यूल्स और द नेगेटिव आयंस. ओके, एंड दिस इज इक्वल टू द कोऑर्डिनेशन नंबर और एंड इज फिक्स्ड फॉर अ मेटल. मतलब फिक्स फॉर अ मेटल हो सकता है कभी कभी सेम मेटल 4 या 6 दे दे, बट मोस्ट ऑफ द टाइम्स वन मेटल इक्वेट्स टू वन सेकेंडरी वैलेंसी. ओके, सो मैंगनीज का है 6. Some metals show 4 and 6 both. We'll look at those examples as well. If you want, you can look it up. 2, Deepanvita, 2. I don't understand what you mean by 2. Good evening, Chari. Sorry, I don't know how to pronounce that. So, this spatial arrangement of the secondary valency, that is known as coordination polyhedra. Polyhedra, octahedra, tetrahedra. Yeah, that's what we're talking about. So, ये square bracket के अंदर जो है, which is the complex, this is what is called a coordination entity. And जो ions है उसके बाहर, those are called the counter ions. This may seem like a repetition. हम लोग अभी nomenclature कर रहे थे, उसमें सब डिटेल में हम लोग ये already देखे थे. Exactly, right? In the nomenclature bits, just to figure out nomenclature क्या है, you need to know all of these things. Although we didn't formally study it, but that's what it is. इन दोनों में फर्क क्या है? This is oxidation number, this is a coordination number, primary valency मतलब in bracket say cobalt 3, right? And this will be cobalt say H2O 6 3 plus, right? So ये 3 plus आया इधर से and ये 6 भाई इसको थोड़ा erase कर देना है, 6 ऊपर चला गया. This 6 is the secondary valency, ठीक है? Non directional मतलब it doesn't decide the shape or anything else. Directional का क्या मतलब है? We'll study when we do CFT. This is one of the problems of this theory. Yeah? It was not able to figure out कि भाई ये directional कहाँ से और what does this mean? कि अगर नंबर 4 या 6 है मतलब कि कोई ऐसा शेप बना वैसा शेप क्यों? Why? That's what he was not able to figure out this. Non-ionizable मतलब कि ये 4 या 6 या whatever it is, these don't split up. पानी में डालने से it doesn't give you ions. Whereas this is what is responsible for the ions, the counter ions and all of that. ठीक है? So these are the common geometrical shapes: octahedral, tetrahedral, square planar. Both of these are given by the coordination number 4. This one is given by the coordination number 6. Okay, here is, look at this beautiful 3D model of cobalt surrounded by 6 amine atoms. Okay, what is the name of this? Hexamine. सही है कि नहीं बता दो please, help me out with this. Hexamine what? Cobalt 3, right? I know पूरा नहीं लिखा मैंने. 3 plus, right? Okay. And let's, what is this? Nickel carbonate. ये टेट्राहाइड्रल है. अरे ये तो लग रहा है कि न्यूट्रल है. NiCO4. कार्बोनेट नहीं, क्या बोल रहे हैं भाई? कार्बोनिल. टेट्रा कार्बोनिल निकल. Is that how what you would say? What would I say here? टेट्रा क्या बोलेंगे इसको? कार्बोनिल बोलेंगे, क्या बोलेंगे? हेल्प करो थोड़ा मुझे. Maybe I'm not so sure about this one. हाँ, कार्बोनिल बोलते हैं, क्या बोलते हैं इसको? Hexamine cobalt 3. Absolutely right, Rajanya. Yes, Rajanya has named this correctly. नामकरण बहुत अच्छा किया. इस वाले क्या? What about NiCO4? This is tetrahedral. But look at this. Platinum Cl2 minus. इसका क्या होगा? This will be tetra chlorido platinate. Platinum से platinate. And इसके अंदर होगा 4 पूरा 2 माइनस. नाम ठीक लग रहा है कि नहीं? नाम अगर ठीक नहीं लग रहा ठीक कर दो यार, प्लीज हेल्प मी आउट अ लिटिल बिट. हेल्प मी आउट. हमने इतना पूरा सेशन किया अभी इस पे. टेट्रा कार्बोनिल निकल. ओके, ऑसम, ठीक है. यू हैव गिवन मी दिलासा कि ये सही है. व्हाट अबाउट दिस लास्ट वन? टेट्रा क्लोरिडो प्लैटिनेट 4. इज दैट करेक्ट? है कुछ और नाम होना चाहिए? ये वाला बोल रहे हैं स्क्वायर प्लेनर है. अजीब बात है ना. इसका विचार, इसका विचार. एक का है स्क्वायर प्लेनर. स्क्वायर प्लेनर मतलब एक प्लेन में चारों हैं, राइट? और एक का है भाई टेट्राहाइड्रल. अजीब बात है. टेट्रा क्लोरेटो प्लैटिनेट 4. क्लोरेटो है, क्लोरिडो होगा. क्लोराइड से क्लोरिडो होगा, प्लैटिनेट पता नहीं यार. देख लो, तुम लोग ट्राई कर लो. ठीक है. खैर, the things that this guy could not figure out. Okay, firstly, why is it that only some atoms, manganese and whatever, cobalt, nickel, all of these form? Why doesn't something like potassium, sodium ये क्यों नहीं बनाता है? He had no way. He did not know क्यों है ये. ठीक है. अरे यहाँ पे दो लोगो आ गए. एक सेकंड, लोगो हटाया जाए. These small things really bug me. So we will fix that quickly. If I can find out कहाँ है हमारा दोस्त. Here we are. Slide number 38. Give me half a second. ठीक है. Yeah, thing like this bug me. खैर, go on in the chat. Go on. अपने ideas मुझे बताइए. We'll get back to it very quickly. Rajanya, what are you saying there? Tetrachlorido platinate 4. Thank you so much. Thank you so much. Absolutely right. Absolutely right. That's great. So that was one idea, right? And bonds. Here. Why do they have directional properties? मतलब कि क्यों कुछ बन रहे हैं प्लेन में, कुछ लिगेंड्स के साथ बॉन्ड, क्यों एक ऊपर 3 नीचे, मतलब टेट्राहेड्रल? What is the directional business for that? This is direction, right? This is in the plane. This is in between planes, right? Keep this in mind. By the way, ये in plane, plane के ऊपर, plane के नीचे. This has to do with the same idea of orbitals. Which orbital does what thing go into? ये हम लोग अगले सेशन में करेंगे CFT में. But there is a concept of x square y square orbital or x or z square orbital या xy orbital, या मैं d की बात कर रहा हूँ obviously, d x y y z etc right? So x y y z and zx are in between orbitals. X y y square and z square are in plane with it, right? ये याद रखना. This is the forms the basis of whether something happens in plane या फिर tetrahedral or something else. ठीक है. Anyway, why do they have magnetic and optical properties? Optical properties है. Magnetic तो आपको समझ में आता है ना. If it diamagnetism, paramagnetism. Optical क्या है? होल्ड ऑन टू योर हॉर्सेस, वील डू इट। खैर एक सवाल करते हैं, द करेक्ट ऑर्डर ऑफ स्टोइकियोमेट्रीज ऑफ AgCl फॉर्म व्हेन AgNO3। यार ये तो अभी हमने पढ़ा था वैगनर, सॉरी वार्नर्स theory में, David Warner, David Wagner, I got mixed up, Wagner, Bach, yeah, Wagner is a nice classical music guy. Khair, the correct order of stoichiometries of AgCl formed in AgNO3 and excess is treated with the complexes, all of these as what? भाई ये नीट में पूछा गया, इसमें लाइक आशीष व्हाई यू आस्किंग क्वेश्चन लाइक दिस मैन, दिस जस्ट अ थ्योरी क्वेश्चन, नीट में पूछा गया था 2017 में, इसलिए मैं आपसे पूछ रहा हूं, व्हाट डू यू थिंक? या गुड जॉब देवांशी एंड राजन मुखर्जी जी एज वेल, व्हाट डू यू थिंक, इस सवाल का जवाब क्या होगा बताइए? What's the answer to this one? Okay, Devanshi. 3, 2, 1. Excellent work. Excellent work. Ujjwal. Devanshi and Ujjwal getting this right very, very quickly. Very, very quickly. Awesome. Rajanya and Tirtha Vaishnavi as well. Sweet. अगला सवाल देखते हैं. 0.02 moles of this compound, penta, amine, bromo, cobalt. Cobalt कितना वो तुम figure out. You figure out cobalt what? Okay, that is, I'll give you the answer if I tell you that. Cl2 and 0.02 moles of same thing but एक instead of bromine यहाँ पे अंदर क्लोरीन है, SO4. अच्छा सेम नहीं है, थोड़ा अलग है. Are present in 200 cc of a solution of X. Then number of moles of the precipitate of Y and Z that are found when the solution X is treated with excess silver nitrate and excess barium chloride respectively is what? देखो पहले वाले के साथ मैं ऐड कर रहा हूं सिल्वर, क्या कर रहे हैं हम लोग, सिल्वर नाइट्रेट, तो बन जाएगा AgCl. दूसरे वाले के साथ हम लोग कर रहे हैं BaCl2, तो BaCl2 प्लस whatever this is plus XSO4 will give you BaSO4. ठीक है, ये है रिएक्शन आपके. ठीक है, डज दिस हेल्प? जल्दी हो गया? यू वांट टू रिपीट एनीथिंग? दिस इज XCl2. ठीक है, Ba एंड इसको मैं साथ में लिखता हूं, राइट? X मतलब X डैश लिखता हूं. ठीक है, X डैश Cl2 बिकॉज यहां Cl2 लिखा है प्लस AgNO3 will give me AgCl but 2 moles. बैलेंस करो बैलेंस करो बैलेंस करो रिएक्शन. ठीक है, did that help? Did that help? Are present in 200 cc of a solution X. The number of moles of precipitate of Y and Z कितना होगा? हो गया ना यार आंसर? हो गया कि नहीं हो गया? देखो, the quantities of X and X dash, X is the first ion, X dash is the second ion, right? The quantities of them, both of them are the same. और देखो मैंने रिएक्शन स्टोइकियोमेट्री से लिखा है, ये BaSO4 मिलेगा प्लस ये XCl मिलेगा, राइट? 2XCl मिलेगा. यहाँ पे क्या मिलेगा? AgNO3 plus X dash Cl2 give you 2 AgCl plus क्या देगा आपको? It will give you X dash NO3 twice. अरे क्या लिख रहे हैं हम लोग? NO3 twice. This is what it will give you. Correct? बैलेंस है रिएक्शन? ये बैलेंस नहीं है, इधर 2 आ जाएगा. हाँ अब हो गया बैलेंस. हाँ हाँ, वेरी नाइस देवांशी, लविंग दिस. ब्यूटिफुल ब्यूटिफुल ब्यूटिफुल. एम्स 2016 का सवाल लग रहा है कि मुश्किल सवाल है, बट ये तो देखो स्टोइकियोमेट्री का ही सवाल हो गया ना. द मेन थिंग यू हैव टू रियलाइज इज व्हाट इज हैपनिंग, कि भाई वो जो डरावना वाला जो कंपाउंड है ना, आपको उसके साथ कुछ नहीं करना है. यू जस्ट हैव टू टेक इट एज X, बिकॉज आप उसको पानी में डालोगे ना, इट विल गिव यू, इट्स अ 1:2 कंपाउंड, मतलब इट गिव यू X whatever plus ions, okay, obviously 2 plus, right? X2 plus ions and 2Cl minus ions, right? Whereas second one which is X dash, इसको अगर मैं बोल रहा हूँ X dash और इसको बोल रहा हूँ X, इसको मैं पानी में डालूंगा तो it will give me X dash 2 plus and SO4 2 minus. दोस्तों, Devanshi seems to have figured it out. What about the rest of you? Are you figuring this out or not? हाँ, ये ratio 2 is to 1 है. That's all that's being asked for. नाइट्रेट है यहाँ पे, क्या हम लोग कर रहे हैं? BaSO4 and this. कौन सा वाला था इधर? So you've got 0.02 moles of first one and 0.2 moles of the second one. And ये पूछा जा रहा है कि moles of precipitate Y and Z कितना होगा? D. A lot of you are saying D. Aakash and Rajan are also saying D. Can you guys help your friends who have not gotten the answer already figuring out में कि कैसे आप लोग में मिला? I've given you this reaction over here. Did that help? Did this reaction help? Did you do it in a different way? What did you guys do? आप लोगों ने कैसे किया इसको? Tell me please. बताइए. Yeah, yeah. So it's as simple as saying कि देखो यार, पहले वाले में थे क्लोराइड आयॉन्स दो, ठीक है, मैंने इधर उल्टा लिख दिया, बाय द वे, इधर एक्स डैश ये नहीं होगा, इधर होगा, दैट इज व्हाट मे बी थ्रू यू गाइस ऑफ, या AgNO3 एक्स डैश Cl2, मतलब दिस इज एक्स डैश एंड दिस इज एक्स, राइट? तो दिस the second one gives you 2 moles of precipitate, okay? So this compound, what I've highlighted here, gives you 2 moles of precipitate. So the ratio is simply going to be what? बताओ, जल्दी बताओ. Yeah, we good? Any doubts here, guys? Are we all right, or is this confusing, or what's happening here? Yeah, a lot of you have given me the answer. I'm just waiting to see if anyone else is giving me the answer. All of you are right, absolutely right. It is 0.04 and 0.02. 2:1. Thank you, thank you, thank you, thank you. Okay, sweet. 2:1 क्यों? क्योंकि भाई 2 क्लोरीन एटम है इधर, इधर 1 सल्फेट है, दैट्स ऑल, सिंपल एज दैट, ठीक है? ओके, ऑसम. What is VBT all about? यार ये तो आपने पढ़ा हुआ है केमिकल बॉन्डिंग में, नहीं पढ़ा है तो इट्स ओके. Whatever valence bond theory was done, it was extended to coordination by a good friend, Linus Pauling. Linus Pauling, have you heard the name Linus somewhere else? Yeah, the tech guy. VBT 1931. Look at him. Wow, that's fascinating. Cool artwork, isn't it? So the goal that he said was, okay, a formation of a complex is a reaction between a Lewis acid and a Lewis base. Now Lewis acid हो गया आपका metal, Lewis base हो गया ligand. That's it. It's as simple as that. And there is a formation of a coordinate covalent bond or a dative bond. Hence the name coordination chemistry. ठीक है? So it uses the concept of hybridization, and again, right? The problem with hybridization is it works really well for sp3 and all of that. But the moment you go to sp3d2 or stuff like that, that's not going to happen. You can say that S और P की energy similar है, but D की energy कहाँ same हुई यार as compared to these, right? No way. Like 3P and 3D don't have the same energy. बहुत फर्क है. तो this again had a problem. I'm giving you what the theory is right now. मैं पढ़ा रहा हूँ आपको, but keep in mind कि ये will get you marks in the exam, but in reality is not how things happen. बहुत जरूरी है ये, especially जो D block वाली चीजें हैं, the VBT works really well for sp3, ठीक है? But as soon as D block elements come, sp3, sp2, sp, great. But D जैसे आगे, things get murky. But with that disclaimer, let's go ahead and study things further, right? Theory है कि n-1 D electron, मतलब 3D and 4s, right? They combine and you get, 4p also. ये सब combine करते हैं, etc., etc., and give you. Khair, anyway, these hybrid orbitals are allowed to overlap with ligand orbitals that donate electron pairs for bonding, and they have equal strength and directional nature. ये directional का idea क्या है? Don't worry, हम लोग CFT में सीखेंगे. VBT gave you a bit of an idea, right? And we're going to focus. Let me show you an example, right? The number of n-paired electrons measured by the magnetic moment. Oh yeah, this is very interesting. So VBT was able to explain कि जो magnetic property आ रही है वो क्यों आ रही है? Why is it that you have some sort of a magnetic moment? But quantitatively बोल पाया था, qualitatively नहीं बोल पाया था. What do I mean by quantitative? Quantitative मतलब कि कुछ idea है कि इसकी वजह से बन जाता है कुछ sort of magnetic moment. But exactly whether the magnetic moment will be 2, 3, 4 or 5, we don't know. That was the drawback of this guy. I'm not going to sing that. I'm not going to do the Star Wars thing again. That's the same thing that's happening here, right? Lewis base आ रहा है, Lewis acid, and it forms molecular orbitals. Okay, look at that. That's it. This is the coordinate covalent bond. All right. This is the same thing that sir in 1 Cl is 2 and in 2 Cl is 1. Yes, Devanshi, you did an excellent job, Devanshi, by answering that quickly. बहुत बढ़िया काम किया आपने. ठीक है. So because of this, you can predict the shape of the complexes and get to this magnetic moment वाला idea. So let's look at how it works with different coordination numbers. अगर 2 है तो sp है. Oh, this is very similar to what you do in carbon bonds, right? Triple bond में भी होता है ये. But I'm going to erase this triple bond business because it may confuse you a little bit. For now, we are only forming single bonds. Okay, that's important. And anyway, hybridization only always talks about sigma bonds. That's important. This may come as an assertion reason wala idea. Hybridization only talks about sigma bonds. I'm going to repeat that one more time. Hybridization, sigma bonds. कभी भूलना मत ये बात. अगर कोऑर्डिनेशन नंबर मेटल का 2 तो बनेगा हाइब्रिडाइजेशन. sp मतलब होगा शेप लिनियर. ओके. sp2 यानी कि ट्राइगोनल प्लेनर like bf3 in regular coordination, in regular chemical bonding. अगर है 4 तब things हो जाती है interesting. Okay, sp3 and dsp2 you have tetrahedral and square planar, and this last type of d orbital, this becomes little bit interesting. इसका कारण we will do in CFT as to why on earth भाई क्यों है ये कि मैं बोल रहा हूं कि DSP2 में dx square y square हो रहा है और sp3d में dz square हो रहा है. What are you talking about, guys? Like, what is this even doing, right? Yeah, so we'll figure that out. But remember, agar say if my head is the metal and my hands are the ligands, you can see that they are in the same plane, right? Like you got 2 here and 2 here. So that's exactly how cisplatinate works, right? So if it's in the same plane, it's x square y square. अगर ऐसा है ऊपर जा रहा है, then it's dz square. If it's somewhere in the middle, that is xy, yz and zx. तो बीच वाले होंगे, you'll see very quickly. Yeah, look at this. The d orbitals over here are both of these. Octahedral में सब हैं. Yeah, x square, y square and dz square. In this case, you've got just a square planar ones are here. Okay, cool. ठीक है. Anyway, this in detail we'll do when we do CFT. This last part बाद में करेंगे, but there are 2 possibilities in octahedral, which is sp3d2 and d2sp3. इसका क्या मतलब है? अंदर और बाहर, inner and outer orbital complexes, we'll talk about that. Non-axial and axial respectively. Thank you. That's a lot better than whatever exercise stuff that I was doing like this. Sigma bond. Yes. Coordination number 4. Here's an example. NiCl4 2 minus. इसका एक्सपेरिमेंटल न्यू वैल्यू इज 2.5 बोर मैग्नेटॉन. ओके, तो मैंने एक्सपेरिमेंट से फिगर आउट किया है कि इसका आई हैव गॉट दिस वैल्यू हियर. सो दिस इज पैरामैग्नेटिक. क्यों? क्योंकि इट हैज अनपेयर्ड इलेक्ट्रॉन्स. ओके, व्हाई? लुक एट दिस. This is beautiful. You've got 3d, 4s and 4p, and what happens is that all of them combine and form, well, not all of them obviously, the s and the p, they combine and form sp3 hybridized orbitals. Yeah, and that is what leads to the formation of these guys here. So 4 chloride atoms, go ahead and put 2 electrons each in the empty sp3 orbitals, right? And that's how you get a tetrahedral complex. Do you want to see that again? And this is called a high spin complex. Why? Because it has unpaired electrons. Low spin is something where things get paired up. We'll talk about low spin later. Do you want to see that one more time? Let's just play that one more time. Okay. Any doubts here, guys? We'll check out the animation एक बार फिर से. You've got 3D, you've got 2 unpaired electrons, and then 4s है, 4p है, सब खाली है. तो 4s और 4p में combine करके बन जाते हैं sp3 hybridized orbital. अगर उसमें देने को तैयार है chlorine atoms. Chloride atoms are ready to give you electrons. Okay, so you get this whole thing. Buffering? I don't know. I think you're okay. It says that 30 fps all seems to be okay over here. Cool. So अगर वो एनिमेशन came and went too quickly, slowly यहाँ पे फिर से दिख रहा है. Any doubts on this? This is important. Okay, coordination number 4. When you have a ligand like chlorine attacking it, then you get this sort of a thing. Okay, this is a high spin complex, and this doesn't force pairing, right? वो pairing इस इलेक्ट्रॉन को पेयर करने के लिए नहीं फोर्स करता है, इसीलिए you get sp3 and not dsp2. I'll talk about dsp2 right after this. Any doubts on this? Please let me know if you guys have any doubts on this. Okay, now look at this. NiCl4 was का हो गया. NiCN4 2 minus. Similarly, now अब मैं cyanide ions को ले रहा हूँ. This has no unpaired electrons. Buffering. Since 2 लोग बोल रहे हैं buffering, so I will quickly check my connection. It says excellent connection. It also says that things seem to be okay over here. Maybe it's possible that आप लोग को अपना इंटरनेट थोड़ा चेक करना हो. Yeah. Let me know if you can hear and see me clearly. Yeah, I'm gonna go back to the chat. Yeah. All right. Sweet. Buffering. Okay. Hold on. Do you want me to switch my internet connection? What do you want me to do? I think if you reduce the what do you call it, quality. Maybe that will help. Yeah, because here it seems to be saying that things are going okay. There are no drop frames on my this thing. So yeah, cool. I'm going to continue here. Okay. So if there are no unpaired electrons, then there is no magnetic moment. This is diamagnetic. So what happens here is, look at this. In this case, ये देखो फर्क ये है कि इसमें भी Ni2 plus has this, but this forces pairing. तो ये बन जाता है nice paired thing, and what you have is DsP2. ठीक है. So दो P के यूज कर रहे हैं, एक S और एक D, and this is an inner orbital or low spin complex. Yes, absolutely right, Rajanya. Absolutely right, Rajanya. Yeah. Yes, in the previous example, but in this example it is. Oh, Vaishnavi, that's really weird, huh? 144p. Yeah, that sucks. Maybe YouTube is being weird then. क्या करें? कभी कभी होता है. खैर. So, what is an inner orbital complex? Where the ligand forces pairing and causes d orbitals to become a little empty. और वो धक्का देखे, like you know how it is, where in a train coach, you can only 8 people can sit, but then दिन में और लोग आके बैठ जाते हैं धक्का देके. That's what's happening practically. Yeah, in the complex formation, the inner d orbitals are used in hybridization. That's because something forces pairing. Okay, so that's a strong field ligand. Strong field हमने नहीं किया है. We'll do it later on. Strong field मतलब pushes pairing. Weak field मतलब still it's okay. Pairing करने की जरूरत नहीं है. Okay, that's the outer orbital, the weak field ligand. Okay, let's look at 6. 144p is ridiculous. I don't expect you to do that. I mean, I think a minimum of 480p would be good on this. 720p is ideal. Although I'm streaming in 1080p. That's my stream quality. 720p should be good. उससे कम maybe a little weird, but could work because आवाज सुनना जरूरी है और text बड़ा बड़ा यहाँ दिख रहा है तो it should be okay even at 480p. खैर, anyway, adjustments. Coordination number of 6, cobalt, what is this? Hexacyanido, cobaltate 3. Yeah, that's what this is. अरे इसमें unpaired electrons नहीं है. कैसे? Because again cyanide has forced pairing. Look at this. Cobalt 3 ions हैं. ठीक है? But look at what happens. Medical student NEET helping me. Thank you so much. Look at this. Look at those beautiful amine atoms, doing a matrix thing, and they're gonna like wham. No, we're waiting. Look at that. Slowly and steadily forming bonds. Okay, there you go. So, what cyanide did, what is it? Forced pairing of these. It's supposed to have 2 more right here, right? But un dono electrons, they went back here, and these 2 got freed up, and what you have is D2sp3, right? Let's see that properly. Yeah, it's quite beautiful, right? Nice 3D animations. Okay, so you have 3D6. Do you want me to talk about this 3D6 business? Are you guys okay with this? Yeah, इसमें कोई doubt तो नहीं है, right? I can quickly do that again if you want. Look, how did I write 3D6 cobalt 3 plus का? I'm assuming you guys are already good with this. But अगर ये चीज भी थोड़ी अजीब लग रही है तो I can do that quickly. Cobalt का atomic number क्या होता है? 28. Is that correct? कुछ अगर random बोलो तो please help me out. 28 कैसे बना? 18, which is argon, right? Plus 10 electrons. अच्छा, 10 electrons कहाँ पे थे? Argon, फिर 3D8, फिर 4s2. ओके, 3D8 4s2 और फिर हमने कुछ अजीब हरकत की है यार. 28 है कोबाल्ट का 26 है. Did we mess something up? नहीं, this is good. Okay, cool. So, cobalt is 27, isn't it? It's not 28. हाँ, see देखो, हमको कुछ याद ही नहीं रहता है, इसलिए मैं पीरियड टेबल हमेशा खोल के करता हूँ. This is funny. Yeah, there you go. 9. Cobalt is 27. Yes, not 28. Who remembers these things, man? खैर, चलो, फिर 3 इलेक्ट्रॉन अगर हटा दोगे तो ये 2 चले गए और बन गया 3D6. That's how you get argon. ये मेरे सर के पीछे है. I know. Oh, it's not. Okay, great. Argon and 3D6. Okay. Now 3D6 अगर मिल गया, then you do this pairing वाला business. Yes, strong field ligand. But ये cobalt 3 plus कैसे आया? I did not do it for the earlier ones, but I hope you're able to figure this out. Cobalt is 27. Yeah. I don't remember these things. It's okay. I don't have to. Periodic table, guys. Just खोल के देख लो. It's okay. Yeah. Awesome. Khair. This is an inner orbital or a low spin complex. This is because electron pairing happens because of cyanide ions. ठीक है? This is D2sp3. 3D7 4s2. Yeah, exactly. Good stuff. Chalo. What about cobalt? This guy right here. This is a weak field ligand. I know I haven't taught you what is weak field versus strong field, but it's okay. कर लोगे आप लोग. बहुत हाई है इसका बोर मैग्नेटॉन, मतलब दिस मस्ट हैव मे बी 4 अनपेयर्ड इलेक्ट्रॉन्स. या हाउ डिड आई गेस 4? बाय द वे, देयर इज अ ट्रिक टू दिस, देयर इज अ स्मॉल ट्रिक टू दिस. रूट ऑफ n into n+2 हम लोग बाद में कर लेंगे, बट ये डीएनएफ ब्लॉक में ऑलरेडी कर चुका आपके साथ, राइट? दिस हाउ यू गेट द बोर मैग्नेटॉन बिजनेस. अगर n है अनपेयर्ड इलेक्ट्रॉन्स, राइट, this how you get the magnetic moment, right, in Bohr magneton is given by this formula. अरे बिल्कुल मेरे सर के पीछे आ गया, तो this was a bad idea. Huh? Anyway, so if n is the number, what you get root of n into n+1, n into n+2 is very, very, is it n into n+1? n into n+1, and yeah, I told you this, Deepanvita. Okay, awesome. n+1, n+2, whatever the formula is. Okay, जो भी है, but basically it's little bit, you know, somewhere around number 4 itself. So 4 होगा तो 4.8, 4.9 होगा, 3 है तो 3.7 होगा, 2 होगा 2.7 होगा. With that you figure it out. Okay, small tricks to do these things. Anyway, yeah, absolutely right. Halides are weak field, इसीलिए pairing नहीं करता है. This is again 3d6, yeah, 4s2, 3d7, and then ये हमने उल्टा लिख दिया, right? Yeah, 3d7, 4s2, argon, that is this thing, and then CO3 plus में बन जाएगा argon followed by 3d6. Okay, sweet. So then this, there's no pairing that happens. There are 4 unpaired electrons. अब बन गया आपका shape octahedral. Yes, unpaired electron. Awesome. What are the limitations of valence bond theory? First one, lot of assumptions. Lot of assumptions, right? The biggest problem is, bhai, D and P don't have the same energy. How is it going to form? Like, ये नहीं होता है लाइफ में, right? D और P साथ में नहीं interact कर सकते. That doesn't happen. Okay. That was the first problem, which we don't teach in NCERT. That's a problem, but that is a problem. It doesn't talk about this number वाला business. मैंने आपको बोला ना, under root of n into n plus formula n+1 n+2 है. एक बार देख ही लेते हैं यार. मुझे याद नहीं रहता है, but आपके लिए तो जरूरी है. For you, it is important what the formula is. But because NEET में you can, you know, you have options. You can figure it out with the hack that I gave you. What is the formula for Bohr magneton calculation? आप लोग बता भी दो मुझे तो अच्छा होगा on the chat. That will be nice. Yeah. मुझे तो बहुत स्कैरी चीजें ऑनलाइन मिल रही है. 4 pi something 1 है. ओके, थैंक यू. आप लोग बोल दिया तो आई ट्रस्ट यू. n into n+1. ग्रेट, ऑसम, ठीक है, चलिए, गुड गुड गुड. इट डजंट गिव यू दिस, ये फॉर्मूला नहीं देता ये, सो यू कांट डू दिस. ओके, एंड कलर कैसे आया भगवान भरोसे, कलर कैसे आया किसी को मालूम नहीं है. दिस इज नॉन एज dd ट्रांजिशन. There is a small kind of splitting that happens within the d orbital itself. Okay, that is what crystal field theory fixed for this. Khair, it does not tell you about the quantitative idea of the thermodynamic kinetic stabilities of coordination compounds. इसका क्या मतलब है? I'm going to talk about statement number 4. What is thermodynamic and kinetic stability? Cobalt के साथ है NH3 6 3+. इसको मैं पानी में डालूं, हीट करूं, कुछ भी करूं, ये ऐसा ही रहेगा. How do I get NH3 outside the coordination sphere? मुझे बहुत पापड़ बेलने पड़ेंगे. It is possible. It is possible through some reactions to take some things out of the coordination sphere. But why is it that it's stable? We was not able to figure out using this. n+2 है? अरे, okay. Devanshi is saying n+2 है? यार, what is the formula of Bohr magneton and its expression? अरे मुझे फिजिक्स की चीजें आ रही हैं यार इसमें. When I say Bohr magneton, for क्या बोलते हैं, magnetic properties of, let's figure that out. Spin only magnetic moment. हाँ, that's what it is called. n+2 है भाई, n+1 नहीं है. देवांशी, good job. It is n+2. Thank you. Split happens when ligand binds with central atom. भाईजान, दोस्तों, देवियों, सज्जनों, formula is not n into n+1 यार, is n+2. सही लिखा था मैंने. तुम लोग मुझे भी डाउट देते हो. And I trust you completely. I changed the formula also. मैंने लिखा था n+2, आपने बोला n+1, हमने कर दिया n+1. देखो यार, तुम लोग तो थोड़ा ध्यान से करो. I trust you completely. I'll do whatever you say. But this is the right formula. ठीक है, n+2 है, it's not n+1. n+1 है, राजन्या, मुझे तो अभी ऑनलाइन n+2 दिखा. या हियर, स्पिन ओनली मैग्नेटिक मोमेंट. देयर यू गो. ठीक है, खैर, ओके. एनीवे, मैग्नेटिक मोमेंट का यही. ओके, लेट मी गो बैक टू दिस चैट. वन मोमेंट. दिस इज डिफरेंट फ्रॉम द फॉर्मूला दैट यू आर टॉकिंग अबाउट. इट्स ओके, इट्स ओके अगर आपको फॉर्मूला याद नहीं, यार मुझे भी याद नहीं रहता है, बट यू हैव टू मेक नोट्स. I can get away with not remembering formula, right? एग्जाम तो आपको देना है. I can just look it up and say, "Arey, yeah, this is the right formula." You have to give the exam. It's okay. It's okay. No problem. Make notes. You'll be all right. Maybe कहीं और n+1 होता होगा. It's okay. We'll figure it out together. You know, साथ में तो पढ़ना है. देखिए आप ही के दोस्त ने एक बताया and we figured it out. कोई टेंशन नहीं है. No tension whatsoever. Okay. ठीक है. Lastly, this whole idea of, you know, अरे keep learning नहीं, रुको यार, रुको. It does not figure out ये शेप टेट्राहेड्रल है, स्क्वायर प्लेनर है, कैसे है कोई मालूम नहीं है. ये जो मैं बीच में आपको बोला था ना, स्ट्रॉन्ग फील्ड, वीक फील्ड, कहां से आया ये सब ख्याली पुलाव कहां से आए, दैट इट डज नॉट एक्सप्लेन. ऑल्सो लास्टली दिस, ligands are not all created alike. Yeah, sure, all of them give electrons, but some of them force pairing, some of them don't, and that was a problem with this. इसलिए हम लोग आगे करेंगे CFT. Now you guys can keep learning. ठीक है, चलो, we are done. This was a shorter class. पहला वाला थोड़ा लंबा था, but I hope you guys enjoyed this, and share this with your friends if you think this is useful. It may have seemed like we covered a lot in just 2 hours, right? But that's all you need to do. You're sorted. Coordination is not that complicated. You do not need 20 sessions, 20 hours of coordination chemistry. कोई जरूरत नहीं है लाइफ में यार. नीट में इतना ही काफी है. ठीक है? Please, 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 NCERT पढ़िए. And if you have any doubts or something, just ping me on IT Chem. I'll direct you to the right resources. आजकल इंटरनेट में everything is available on the BYJU'S site, NCERT, everything is there available, right? कर लो. चलो. Have a good weekend. I'll see you on Tuesday. We'll continue chemical bonding. Yeah, if you guys, I saw some JE folks on the NEET channel. If some of the NEET folks want to go check out my session on the JE channel, you can do that as well. I'm going to be doing thermodynamics for the JE channel on Sunday. Okay. चलो, hey Yuvraj, what's happening? Hey Rudraksh, सही टाइमिंग है आप लोग, सेशन खत्म हो रहा है, आप लोग आ रहे हो, माइक पहना हो ना, थैंक गॉड, आई एम वेयरिंग द माइक. ऑलराइट, सी यू, अमेजिंग सेशन एज ऑलवेज. या मैं इन दोनों के नोट्स आई विल गिव यू ऑन द टेलीग्राम चैनल, प्लीज चेक देम आउट एंड इट विल आल्सो बी लिंक्ड इन द डिस्क्रिप्शन बाय द टाइम यू गाइस आर वाचिंग इट, इफ यू आर नॉट वाचिंग इट लाइव. ओके, ब्रिलियंट वीकेंड गाइस, गुड नाइट, टाटा.